Hello everyone, welcome back to our YouTube channel. In this lecture series, we'll be seeing about Module 1 BEC405A 8051 microcontroller, and particularly we will be seeing the topic on internal memory organization of 8051 microcontroller. So moving on inside the video, what is internal memory organization of 8051 microcontroller? So this is the general structure where you have some working register, general purpose register and bit addressable. So these are the different banks that is available for working register ranging from R0 to R7. So bank 0, bank 1, bank 2, bank 3. And you have some bit addressable value and general purpose register, how it has been split. So based on this general structure, we'll be seeing different units across your internal memory organization. So to see in detail, next is about the different sets that is available in the internal organization of 8051. Now, see, generally program memory is nothing but it is ROM. That is, it is on chip and it is typically a 4 KB in size. And then it stores the program instruction that the microcontroller wants to execute. Actually, this doesn't directly write or it is directly wrote by the user program. The program is written into the ROM during the manufacturing process itself. So moving on to the data memory, that is your RAM, read access memory. This is also a on-chip memory where it has 128 bytes. So your program memory is having 4 KB and RAM is having 128 bytes. So it stores all the data temporarily during your program execution, maybe such as it can be variables, intermediate results or some stack data that has to be temporarily stored. It is actually accessible by the user program just for reading, writing and manipulation. Moving on to the next thing, that is internal RAM organization. So here this is 128 bytes of internal data memory. So it can be further, this internal RAM can be further divided into some special function registers. So here special function registers, you have different special function register like timers or counters. That is, it is used for timing and pulse width modulation. Stack pointer. So stack pointer is, it is going to track the top of the stack for all the subroutine calls and data storage. Here program status word, simply called as PSW. So here it is going to hold the flags, that is overflow flag, zero flag or carry flag. It is going to hold all those flags indicating some outcome of the operation. If you do addition and you have a carry, it is going to give you the carry flag and holds the carry flag telling that it is the outcome of the problem or program or operation. Then input output port control register. So this is nothing but it is the managing the data direction, that is either it should be an input pin or an output pin. For such kind it is used, control registers is used. Finally, serial communication. So this serial communication is giving us the communication that can taken place with external devices as external interface only serially, no parallel communication. Serially it can transmit the datas and communicate the datas with the external devices. Then stack operation. So stack, it is optional, it is not needed for each and every internal organization, but 8051 has stack. So here stack is last in first out data structure or first in first out. So under stack operation you can see you have the LIFO and FIFO, and it is using push and pop operation. So it is used for calling all the subroutine data, temporarily stored data, and it is also using the stack pointer register to make a track that it is always pointing to the top of the stack. Then moving on to the next thing, scratchpad RAM. So it is nothing but it is going to occupy the upper address range, that is the highest range, not from 00. It is going to opt the 20H to 7F. So that address range it will occupy. So it is going to provide some general purpose data storage. So where it is used, where it is being used is, it is used by the user programmers. This is primarily a RAM space where you can store variables, perform calculation, and also manipulate the data during the program execution. So moving on to the last part, that is the addressing memory. So it is the 8051 is a 16-bit address bus, as we all know. But the internal data memory, it is going to occupy only the lower 8 bits, that is 00 to 7F. So separate instruction will be used to access all the special function registers and the data memory location. That is why you are using separate addressing memory. So I can conclude that the ROM stores permanent instruction, your program memory. RAM stores temporary data during the execution. Your special function registers is used to control various functionalities like timers, counters, stack pointers, all those. And scratchpad is nothing but it is going to provide us the general purpose data storage. And the stack is used for calling the subroutines with push and pop operation. So hope you have understood the breakdown of the internal memory organization. Stay tuned for more information. Thank you.